Hey folks, thanks for joining me and welcome back. In this video I'm going to go ahead and make this kind of special fuel distribution tee. Let me show you two right now. Now I realize I don't normally show you the finished part in an intro. I do sometimes as far as a thumbnail goes, but I don't show you it right up front, because I want you to understand the process of designing and engineering it, designing it, and then actually fabricating or machining it into the part that I need. But the part that I need is not going to work. It's not going to work as engineered and designed. It's not that I screwed up on any dimensions or made a hole too big or the spigot's too big or they fell out or something like that. It's I forgot one key element in regards to the orientation or the clocking of the spigots. And we're going to go over that at a later point in this video because all the machining content in regards to making even this one that doesn't work right now, it will work, that I have in my hot little pocket, is valid. Now at some point when we get to that point in editing, I'll go ahead and insert another kind of like sub intro and say, okay, from this point on, this is where we're going to be correcting the issue in regards to what I did wrong and why. We'll explain it at that point. So I hope you understand. I just don't want to confuse everybody if I just kind of segue directly into that, because then you're going to see essentially two different looking parts and be like, what do you make, two of them? So obviously I don't want to make another one. I don't want to scrap this one. We're going to save it. So keep watching the video, you'll see that. And let's go ahead and get with it, and I'll see you at the end. All right, so here's the deal on this 96 VFR 750F carburetor rack, this Keihin rack I'm working on. We have an issue in regards to the fuel delivery to the two sets of carbs. So this is your main distribution fuel tee that comes in from the fuel pump side. See, it's a big Famunga, which is typical for Honda, hose that comes in. And then it drops off to, probably these are designed to be 7.5 millimeter hose. But unfortunately on this side that goes to 1 and 3, this one is molded. As you can see, it turns very sharply. That's a molded hose. You're not going to get a regular piece of hose to make that turn. I mean, I don't know how to do it. And these hoses I've already looked up are absolutely unobtainium. We're not going to be able to do anything with this one. It's got some cracks in the end. It doesn't fit very well on either side. The one going to 2 and 4 is even worse, which is more of a straight shot. So that's the thing that gave me this idea. I mean, you have a straight shot from this tee here right to 2 and 4, and you have a curve shot, if you will, at least a very sharp turn at the beginning of it that goes to 1 and 3. And this would be toward the 1 and 3 side. So this would be the shorter one, this would be the longer one, because 1 and 3 is the rear cylinders, and this is toward the rear, so it comes in from the back, said the wife. What we're going to do is we're going to come up with something different. I think the only way to do this and actually make it work for this viewer is to manufacture a new tee, but manufacture a tee that has two spigots that come out the side like this. So it'll be almost identical to this one right here, and then we'll bring it out to about, because we know this distance is good because this is the way it was on the bike. We'll bring it out so another spigot comes out about right there. Maybe a little closer, I'm not sure yet. The carbs are apart right now and split and everything, so I really can't put them back together. Well, I could put 1 and 3 back together and just get an idea, but I'm pretty sure if we make a spigot sticking out that's about right here maybe, it'll probably be pretty good. And then we'll have 2 straight shots, and that's really the best way to do this. I don't know why Honda really did it this way. I think it costs a lot more money to make a molded line like this than it is to make a plastic tee that's got 2 straight spigots on it. I don't know why they wouldn't do that. So that's what we're going to try to do. There's just no other way to solve this problem besides reusing all or part of this hose, which is really not professional in my opinion, and I don't think it's going to work in the long term. We could probably put this hose back in. It might work if we put some different kind of clamps, but this stuff is really stiff and, brittle. I just don't think it's going to last very long. Like I said, it's got some fine cracks toward the end. Not so much on the 1 and 3 one, but the 2 and 4 definitely. So we're going to machine it a little differently. I'm going to try some different stuff here because I don't necessarily want to take a piece of stock like this, like I normally do, and just turn the ends down to whatever the size I need, and then make the little barb on the end, and then press spigot in, or spigots in this case. I would like to make this more oval shape, offset, and put the hole over to the side a little bit. So essentially what I'm talking about is, if we do this, I would like to put, well actually let's do it this way. I'd like to put the hose, and the hole rather, for the main inlet over to the side and leave a significant more amount of material. Let's actually be about like this. Let's slide this out of the way and do it this way. I know it's kind of hard to see on camera, but if I offset this so it's kind of toward the one side of it, and then leave the bulk of it up here for the spigots. And I don't know what ultimate diameter this thing is going to be. This is going to be kind of a work in progress and experimentation as we go. But I think that's going to be the best way to address this, because it gives us the most material and the smallest footprint inside there. There's just not a whole lot of room back there that I think, you know, because everything's so tight. It's tight into the carb. I want to keep it as tight as possible. So I think that's the best way to do this, and that gives us the best material thickness for spigots. And I think it's going to be better than like a square or a rectangular piece. So obviously I have the 4-jaw installed on the spindle nose, and it's all ready to go. And I think what we're going to do is we're going to put a piece of stock in, and I think the first thing we need to do is just true it up like we normally would in a 4-jaw. And then we're going to experimenting with offset. I'm going to try to just offset one axis, because if we offset it like this way, it's kind of going around this way. And it's still doing that when it's offset just in one axis. But I'm going to try to keep it just moving side to side. And I don't know how much to offset it. I don't know if it makes any difference doing it that way. But we're going to experiment and see what we can do with it. I think, no, we're going to use this side. And then, you know, then figure it out from there, because I think that's the best way to go. But I haven't done a whole lot of this, as I said, so what we're going to have to do is have to figure it out as we go, and we're going to have to experiment. So I think I said that already. Anyway, let me get this chucked up, and we'll indicate it in, and then we'll figure out what we're going to do from there. That's pretty close, actually, so let me just get an indicator on here and see where we're at. All right, I'm going to move this way, so I'm just going to back off this top jaw, jaw? What am I, from Long Island? 100 thou, so I have to kind of get in here. Let's turn this. We'll back this one off a little bit. I don't know if 100 is going to be too much. Maybe we'll do 50 and try that instead, yeah. So right now we're at about 15. I just don't know. I don't have much experience with this. I'm sure there's a calculator out there that tells you how to do this. But I just want to see what it looks like in regards to just taking a little test cut. And then we're just going to go off of eye if it looks good. And we're going to run that thing down to whatever oval diameter or oval size that we choose. That's what we're going to do. 55 is good. That's fine. All right, so as usual, I'm confused. And I tried some. Doesn't work, but it will work. So I'd like to show you my mistakes on this channel, and this is one of them. So I just cut this off with a hacksaw. The problem with this is if you just start turning this offset, all you end up doing is bringing an offset section concentric with the spindle bore, and it really doesn't help you at all. I was thinking we could leave this into an oval shape, which you could if you only took like half of it, but then it's not really an oval shape. Part of it's one radius and part of it's another. So what I was thinking was wrong and right. What we need to do is we need to shove the hole in offset. That gives us a thicker side on one side or another. And then what we can do is, assuming we don't move it over too far, because you know I offset this 50 thou, so I think that's 100 overall. But then again, it should be just 50 because we are dealing with the center and we're not cutting on both sides, so it's 50 thou off. So almost a 16th. If we put the hole in offset and then we put it back in a 3-jaw, or we just indicate it back in and we just turn the whole thing normal, we may be able to bring it down to a diameter where we're still offset, but we're a little smaller diameter, which I think we need to have for that particular space limitation that we have inside there, which is represented by this guy. I mean, that's a hell of a lot bigger than that. So if we put the hole over here and we just turn the overall thing, then we're going to have not too much of a wall on the other side. So I'm not really sure how we're going to address this yet. The other thing we could do is take this and drill it, and we can put it in a collet chuck, and we can indicate in, or not indicate, but just kind of index off the side of the hole that's already closest to the edge. And we put in a collet chuck in the mill, and we just do like a hex. And that may be the way to go on this to make it work the way we want. And you know, I'm not sure. Like I said, I'm experimenting here, but I'm trying to make this kind of custom, and I want to offset this. I think it's just the best way to do it. So anyway, let me face this. We can do that in this setup, no problem. Just clean up that face, because now I've screwed it up. And then we'll set up center and drill it out. We'll drill it out to whatever that ID is, which I haven't looked at yet, which is probably 8 or 9 mil. Anyway, let's do this first. Yeah, you see the center here. Let me zoom up on that. The little swirl, the center swirl, that is where the hole's going to go. So you get where I'm going on this. We offset it. And then I think maybe doing it in a collet chuck may be the way to go once we set an offset hole. And we could do that in the mill as well. We'd have to stand it upright and then indicate it in. It's still easier to do it this way. It would be very hard to get this true vertical in a mill, even with a collet or something. I mean, not very hard, but it'd be hard enough. So I don't want to, you know, hard is good, but not necessarily here. So what we're going to do is we are going to keep it as easy peasy as possible. Put in a chuck, drill a center, and then we'll drill it out and see where it's at. Again, this is experimentation, so what the hell? What do we got to lose? All right. Now in this situation, if we're going to use this part, we are going to have to calculate the depth we need to make that before it's going to stop. And naturally we have to go deeper than thrust. We need to make it deeper than where the spigot's going to go, otherwise the spigot's going to fall into a solid area, said the wife. So we're going to go ahead and just have to mark that, and again, go by eye. We'll figure out what hole to make this and just push it in and see how it looks, and then take it from there. Okay, that's 8 mil, so that's an 8 mil drill. Got my thing stuck in the hole. That's 2 inches from the tip of the drill. All right, so I think the next thing we do here is we're going to indicate this back in 0, and then we'll just start turning it, which leaves the whole offset to the material. We're just going to do it a little bit and see how it looks. Okay, it's 4 or 5 thou off. Who cares? That's close enough. Now you can see that the hole, now you can see it, the hole is running offset, which is what we want. And we're just going to turn the outer diameter down evenly. We need to reduce this overall diameter. We really need to, because it's just too big. I found it right here. So what was I saying? We need to bring this down so the outside diameter of this is not going to be too thin. And that'll essentially, we'll leave a little bit more too, because we're going to have to turn on that center of that bore. But it will leave a thicker part on one side, which is what my objective was in the first place. You can't see what I'm talking about. Let's go over here and do that. So that's what I'm talking about. We're going to do it this way. So I need to measure this up, the larger part of the barb here. Make sure I leave enough wall thickness. We'll just eye that in. Because like I said, we're going to turn the whole thing down. But I want to get the thickness of this down a little bit more. I can't think of any way to do this like in an offset operation, because if I picked up on the center of that hole, we're back in the same square one. You really need like a CNC where it goes in and out. Now we're going to figure out how overall long we need to make this thing. We're already set up, I think, on the 0. Yeah, we're zeroed out already, so we'll just go 2 1/4 or something like that. Let's try that. Let's see, I'll take 50. Now, 230, 60 overall. not running fast enough RPM is what the problem is. Two 250. Enough. And roughly, we're straight on the inside. We're figuring about 75 thou. And we're figuring about 125 right there. So if we bring it down to 100 or 90 or 80 or something, that's fine. Yeah, I think that edge was pretty bad. Yikes. No wonder it was cutting like shit. You know, you go away for a week and I can't remember nothing when you get back. Like, where was I and where do I live? What's my address, you know? All right, I'm going to whittle this down to where I think it needs to be, and then I'll bring it back. All right, I ran it up to 1,000 RPM, a slower feed, a little bit better, but it's the surface finish I'm not too terribly concerned about. I got enough wall thickness left on the thin side, but you can see overall it's not too much bigger than the original one, which is good. And only the center section after the spigot here is going to be a little bit bigger anyway. So this end section is going to be down to this diameter once we recenter on the hole. So it's going to be up to about there, and then that rest of that section, so essentially be thin here and fat here for the two spigots to make sure we have enough room for that. But the spigots, of course, will be on the high side, or the thick side. And I'll show you how we're going to identify that, because once we're lined up on the center hole, we're going to have a high and a low on this part because it's going to be offset again. And then we'll find the high with the dial indicator and just scribe a line down with the tool itself. We'll just kind of run a line down with the tool. I'll show you when we get to that point. That'll give us the high side. That way when we go in the mill, we just put that up. It doesn't have to be perfect, but as up as possible. In that same exact setup also, we can make a reference mark on each side of that thicker section with the tool as well. Because we know where the high and low side is, we can use that to help us line it up if we want. You know, just kind of bump the tool. I don't know. We'll figure that out when we get to it. But I think I'm just going to really quick recenter on that center hole, and we'll play with it from there. Man, I just moved that by eye, and son of a gun, she's pretty damn close. All right, that's a couple thou, that's fine. There's no sense in going cray-cray over this. OD is what we want to go for. Make sure that's good. Good enough. Probably 10 mil, I bet. So that's like 3, no, that's bigger than that. Doesn't matter, but it's going to be 470. Guys, like I said, this is all experimentation. I really don't know what I'm doing, but I'm trying to do what I can do. Now I want to do 1,000 on that. Let's do 800 again. Eventually, when we clean this whole thing up, we'll just dial in that wall thickness all the way around now because we're on center with that hole. And man, she's going to be beautiful, but that is the larger diameter, so we need to come in after that and make the smaller one because that larger outside is so that little barb area, whatever you call it. All right, we're at 480. The 470 is the big size on the plastic one. We're going to leave it there because we can polish that in, or it doesn't matter, 10 thou. So now we got to come in. I'm going to use different tool, come in a certain amount, and we'll cut that center section in a little bit more. I can only get so far, and then we'll bring this one back in and we'll do the shoulder. because I don't want, normally I would just, if I was making a regular tea, I would just use that 45-degree tool and just chamfer that edge in. But I need to put the spigot as close to this edge as possible, I think. That first spigot, which would go, spigot rather, which would go to 2 and 3. So 2 and 4, I'm sorry. So I can't do that. I'm gonna just bring this tool back in, but I can make at least the majority of it and then do that. I'll just do that right now. And stop talking about it. I did hit it a little bit. Oh, did I? Yeah, I just grazed it. That's okay. Not going to make a difference. We can just bring that shoulder in a little bit further to clean that up. Now we'll bring this back and kind of chamfer that edge. Okay, and then we'll bring this out here and do the same thing. We'll bring that in with a file. It's got to be kind of like a slanted, it's got to be kind of like a slanted taper thing, you know, kind of tapering up and then dropping off. That's what we're going to make it. Whoops, I'm doing the wrong one again. So it's a little thinner than the original, but yeah, it's close enough. Perfect. Now we got ourselves a spigot that looks fairly decent and will work. And we've got a nice thick spot. And look at, we're just a little bit sticking out on the bottom of that thin side, which is perfect. And we could actually come down right to that edge, but I don't need to. And we've got a nice thick section up here that we can put those two spigots in, sticking outwards. And there'll just be a, you know, capped, not capped, but an end that's not, you know, open. And then you got two spigots and they come out straight and Bob's your uncle, it's good. So I really like the way that came out. This is fine, it's just not quite as thick as the other one width-wise, but it's gonna hold the hose fine. Polish it up a little bit, and then I'll show you, we're gonna go ahead and pick up that high, make a mark. I got a phone call, so I kind of forgot where I was at, but I think I was talking about dialing this in close enough to level and straight. Just a little bit, make a little scribe line. It'll just give me a reference for the high side, because I can put this up in the mill to make the, to do the two holes for the spigots, but I gotta make the spigots too, which I know the tool's on center, so it's close enough. You can see that that scribe line looks pretty damn good as far as on the high spot goes. I'm happy with that. So again, when we line it up in the mill, we'll put it, I don't know, just on a parallel with this up high, and we'll just use just a square and bring it up so that's on the top. And it's got to be right, because the sides are the sides and the top is the top, as long as it's vertical, and the square will tell us that. So, all right, folks, here we are over at the mill, and I don't have this workpiece clamped up very tight, just snugged. The scribe line is on the top. I had to make it a little bit longer so the scribe line doesn't come all the way to the edge. So I said, well, it's not going to work using a square. Then I thought about it and said, you know, there's a much better way to pick up this line here to make sure it's pretty exact. I know what the diameter of this workpiece is. It's 607 thou. With it in the vise just snugged up, I can pick up on the back vise jaw with an edge finder, and then just come to the center. Then just put a centering, like a centering pointer, or in my case, a center drill, and just line it up visually to that line. That'll get us, what, within 10 thou or so? So that's really the best way to do that. I don't know what I was thinking before, but you know, I'm going at this job a little differently, because I'm guessing as I go and trying to figure out, make sure I have enough reach here. Being this is not a knee mill, not an email, a knee mill, I have to calculate everything out as far as the distance that I have in the spindle, or the quill rather, as far as it going down and to clear any tools. So I got plenty of room, and I know the reamer will fit because I have a reamer over here. I'll go over that here in a second. So we'll just pick up off, let me turn the DRO on, that'll be nice. Then we'll just use the center function. We'll get the center and we'll line up. I think it'll be pretty snazzy. Too quick. Since we're already in 100, we got to subtract 100 from the width of that 607 divided by 2. So 607, half of 6 is 3, half of 7 is 3.5. So it'd be 303 and a half thou, so 203. We got to move over 203 thousandths basically. We'll use a really tiny center drill. I need to make a pointer up, you know, put it in a lathe and just make a pointer, and then have it for this kind of thing. But now we know we're in the center of the part. All we do is bring over the x-axis. And we'll rotate the part. That looks right on it. Whoops, I keep kicking you, sorry about that. Now we snugged it up good. Give her a little tappy tap tap. So now I'm going to indicate off the, I'm going to go off of the nozzle, if you will, or this main spigot, because I've been going off of that for my depth of the hole and so forth. I don't want to change in the middle of doing something else, so I need to pick a 0 up on that. There's a little trickiness going on in regards to the location of this hole that goes to 1 and 3. This one up front here goes to 2 and 4, but the one around the back side goes to 2 and 3, the one with that bend in the hose. It's kind of confusing and complicated, but I'll try to do the best I can here, either in this clip or any subsequent clips, about the locations of these holes. Now this one is for 1 and 3, so it'd be for the rear carbs, as I've indicated before. So when it's on the carb rack, it's like this, and it comes in from the left side. So this snakes up, and I'll show you some inlet pictures. But this one here has to go in a very tight space between a couple of different, between two different hoses, that big vent hose and another small vent hose that comes down to the outside of the carb. It's very difficult to figure. If I had the carbs all together, I could do a better job at that, but I'm using the photos, and I have a pretty good idea where I can put this second spigot, so it'll essentially be in line with this. So forget about this bend right here. Take it from here down straight. You go here down straight, which would be a straight shot in there, because this thing is kind of pushing up against one of the hoses. That's why it's wrapped, it kind of bends around and goes straight. So it's bent around to go straight to clear that. So if I come straight off pretty much, and if I put a straight edge across here, it'll be about right there. That's where I'm going to end up putting this hole. And I calculated what that should be, and I have this hole depth with an 8 mil drill, because I think I mentioned before I had to make this a little bit longer to accommodate that. Just before the end of this, there's probably about maybe, oh, I don't know, 8 mil, 6 mil of material in here. So, or maybe 6 mil is probably right. It's about a 1/4 inch, and that's what the end of it is. So the fuel didn't just come spewing out the end. So the whole bottom's about 6 mil away. So what I'm going to end up doing is, since I know this depth from that hole, I did it with a depth mic to the bottom of that hole that I drilled. So this inlet to that, I'm going to just put the hole for this one on the edge of where that hole terminates. So there'll be a full hole where the spigot goes, and then one up here as well. The one up here is going to essentially be mimicking this right here. So I'm just going to put it pretty much, pick up on this edge. I need this 0 for that though, so I'll do that first. And then I can go to a different mode in the DRO and pick up another 0 here, and then we can just move in, you know, half the distance of whatever this hole is going to be to put a spigot in, plus a little bit, you know, maybe 20, 30 thou to give it a little bit away from that shoulder. And then we'll pop that hole, and then we'll do that hole based on that depth. So it's a little confusing. I'm trying to explain it to you. It'll be a little bit more explainable when I install it, assuming that the damn thing works. So let's go ahead and set a 0 on the Y. So we're always in the center of the part this way. And we'll come to the end. We'll go ahead and 0 the X now. Now we're on the edge of that part. where this inlet is. I think I'm going to run down here and do this hole first, because this one's going to be a little bit more challenging. I want to make sure that my math that I wrote down in my silly little brain is going to actually work in that situation. That hole depth is 2.290. So if we went right to that, we'd be at the end of the hole. We don't want to be there. We got to come back at least half the distance of the hole we're going to drill in there, which I'm not 100% sure about, but I'm pretty sure it's going to be close to 5/16. This is basically 8 mil on the OD. And what I'm going to do is I'm going to use a 313, a 1,000th over reamer to ream these holes. Then I'll measure the holes up with a little snap gauge to see what they exactly are, you know, because this mill is not, you know, the most accurate thing on the planet. And then we'll make the spigots to fit like we normally do. So that's what we need to do, 2.290 and half that. And then we'll move back half that and maybe 20 thou just to make sure we clear that bottom of that hole. Okay, so half of 312 is 156. And then 2.290 minus the 156 is 2.134. So we're going to move over 2.134 and maybe come back about, I don't know, maybe even 10, 15 thou just to make sure. 2.134, 2.1, 20, 30. So if we were going to punch that hole in right there, it would be right there, which is about where I figured it would be. Now we'll zero that out. We'll leave that at 0 now. I just want to make sure. I don't think 20 thou is going to give us any problem, as long as we got the majority of it in there. As far as the hole goes, I guess we'll find out here momentarily. Let's make sure everything's tight, and then we'll just center drill it and drill it. Put a little anchor lube. Why not? I know I should be running this faster, but I don't feel like changing belts. Plus the reamer needs to be slower, so one of these days I'm going to put a 3-phase motor with one of those VFDs. That should do her. I'm going to punch through with a 7.5 mil drill bit, and I'll tell you right now that this is kind of a tricky situation, because when you know that there's a shoulder or some other irregularity inside that hole you're going to punch into, you got to be real careful when you break through that one of these flutes doesn't catch that, and then all of a sudden either snap it or worse, you know, damage the hole. So we're just going to be extra careful when we go through. I think we're going to use this fine feed, that way the drill bit has no chance of being pulled with the quill. And we'll just put some anchor lube and say a prayer. I felt pretty good. Good. It's pretty much exactly where I wanted it to be, just shy of the end of that hole. So I'll show you that here in a bit. All right. That's that 313 or 1 over 5/16 reamer. Like I said, I don't really care what it cuts at. I just need to have a really clean hole. And this won't use the quill for. I'm liking it. Yeah, so you can see the end of the hole is right up in there, the cross hole. And we're just shy of it, so that's really nice. I like that. Okay, now we're going to pick up on that other edge, set another 0. X is 0 in that mode. Let's go 100. Now on this one, we'll go over the same. No, actually we don't want to, yeah, we want to do that. We go over half the distance of the hole plus a little bit, so we should be able to do this at 156 again, plus a little bit. Whoops. Sorry about that. Okay, so now right now if we punch that hole in, it would come out right against that edge, which we don't want. So this is where a little guesswork comes in.
We'll compare this to this and see how much further in that is. I might just eye this one. Yeah, let me do that. I'm going to put the center drill in, eye it, and we'll put it in basically the same location as this one. That way we know we're off the edge. I'm using this edge right there where the hose would normally bottom out against that little plastic feature. 231 on the DRO, so I was thinking of going even less than that, so I'm glad I did it this way. From here out, it doesn't matter. I mean, you can have this a little bit longer, just as long as it's not too short. Done did. All right, so there we are. There's the two holes. You can see there's plenty of material in those holes as far as thickness goes to accept a spigot, pushing it in there. That's why I did it this way. I think it's going to work out really well. Okay, folks, here we are. I've got the spigots made, and again, I didn't film any of that because you've seen this done 100 times. I got them a little over a thou crush. Everything's cleaned. We'll do this one first, and I want to push it in 200 thou, so we'll use the Z-axis on the DRO. So they want to start. It wants to start, rather. We just use the coil to push it like we have in the past, but right now it's where I want it to be on the Z, so we'll set that 0. I want to push it in 200 thou. 200. It should be sticking out about 650 thousandths. That was a really good feel, too, like very, very tight. Might be up a little bit. I wonder if I can get that in just a little bit more. I don't know if that shit's already done its thing, though. A little bit more. Okay, no, that's tight. Let me tell you what. And we can go over to the, it should be 2.134. I hope you like what you saw as far as this video goes. You'll see this in action again when we go to put the carbs back together and get them completed. That'll be in video 2 on those carbs themselves, as I said. But yeah, I'm pretty happy with the way this came out. All right, so at this point you should be up to speed as to how I made the part and why I did that originally as far as the two spigots and what the purpose of it is to solve the problem with the really tight fuel line, the molded fuel line that is no longer obtainable. So let's go ahead and get right into the section where we're going to go ahead and fix this so we can actually clock the two directions. And we'll zoom up here with the old fuel line so I can kind of show you in detail, and then we'll bring you forward from there. All right, folks, let's take a look at what the problem is with this one. We'll have to use this one to do it. You saw this earlier. When I picked this up after I took it out, it was just like this. And I'm looking at this thing going, well, they're parallel. That's where that line going across when I picked up the center of it so I could pick up the location where I put these two spigots. That's where that came from, because I'm thinking, well, they come out parallel. They don't come out parallel. This is one of the reasons why we're going to fix it the way we are, because we're going to be able to adjust this, because I had it like this and I just didn't look at the photos carefully enough. Otherwise I would have saw it was like that and I would have said, well, I can put this one straight across, but I'm going to have to rotate it a certain amount of degrees and have it coming out kind of at an angle there. I don't want to scrap this, as I said in the intro. I'm going to go ahead and use this, and we're going to show you right now how we're going to do that. But this is the genesis of what the problem, what caused the problem, well, how I caused the problem, because I just goofed up in regards to the engineering. So when you're attacking any problem, you have to ask yourself, what's the objectives? What do you want to ultimately achieve? What we want to achieve is we want to have this one on the right here, which goes to 1 and 3 pretty much straight out, or maybe slightly elevated, maybe like that. It doesn't really matter. As long as it's something we can move around a little bit this way and this way, because this doesn't mount to anything. And we have to have the other one at the appropriate angle, which is going to kind of be like that, like I just showed you. So how are we going to go and do that with this particular piece when there's no swivel in the middle? Now, we're not going to build a swivel, because even if we could, we would just introduce another spot that it could potentially leak, because we'd have to put an O-ring and so forth. You're on the right track if you're thinking that, because what we're going to do is we're going to split this right in half. We're going to cut this in half,
and we're going to find the exact center by picking up on the inside edge of these two spigots. I mean, when's the last time you used the half function on a DRO on a lathe? I've never used it before, but in this video we're going to use it, and that's pretty interesting. So we're going to do is split it in half, and we're going to face the ends of that and figure out approximately how much material we took out to try to keep this distance the same. And then we're going to bore out the inside of this a little bit, and I'll kind of show you a drawing that I made as I discuss this to illustrate what we're going to do. I'm going to turn the fan on because it's getting hot again. What is it, November 11th now or something like that? November 11th, and it's freaking 9,000 freaking degrees still. If we put this inside the 3-jaw, we can straddle the spigot, one of the spigots, just between the jaws themselves. When I'm doing setup and things like this, I never have the lathe on. I leave it off for that reason. I just want to make sure you're in shot here. So again, we're going to keep this spigot between the two jaws like that, and we can still use the 3-jaw because we're working on this outside major diameter, not this one, or not major diameter, the big diameter. I keep saying that. We'll get a good purchase on it, bringing in that much, about a 1/2 inch, 5/8 of an inch. We're going to find the center. I want to cut this at the exact center between those spigots. And why not? Now to do this, we're going to do this is cool. I mean, if you're a machinist type, when do you ever get to do this, you know? You never get to do this with a DRO and a lathe. I can't think of any other scenario but this where you could use the half function. What we're going to do is we're just going to come in here with this tool. This is the tool I use for grooving fuel joints. We're going to go ahead and just we're going to rock this back and forth till we can just get that one side of the tool. Now I'm going to take the Z-axis on the DRO, which I'll show you here. We're going to take the Z-axis and we're going to zero it because the Z is the carriage, all right? Now we'll come back to here and we do the same thing over here. Whoops, Z-half rather, that's the same difference. It always confuses me. So half Z. Now we're at the point where we know the halfway point, 351 thou between the tool and those pieces, those spigots. So now we just go to 0 on the DRO. We're going to come in here, make sure we got clearance. Okay, here we go. See how that's running out because it's offset? Well, that's the hole that goes through this thing, as you know from the machining part of this video where I made this. Goes through and then bottoms in here. Well, because that hole is offset, if I use this little dinky grooving tool to go in there and part this all the way through, it'll start parting unevenly when it reaches that hole. It'll break through the hole into the center of the material on the thinnest spot. And I can guarantee you that it'll catch that tool, it'll snap the tool, and it'll destroy this piece of this workpiece. Because this is not a parting tool, it's a grooving tool, although it would work as that. My parting tool is 125 thou wide, or 1/8 inch. It's way too wide to do this, and I don't have a thin one. So we're going to go ahead and just use this to mark it, and then we're going to come back and do the rest of it. All right, good enough. I'm over here on the Grizzly drill press. Grizzly! Which has magical properties. Let's go ahead and we'll take my Cabela knife. This has magical properties also. And we'll go ahead and we'll just cut this in half with this. Works every time. All right, we're back over at the lathe. We're gonna face each one of these pieces off, and I already see a problem that I didn't consider before. The offset hole doesn't leave much material down the bottom end to bore out the center of it to make something to press on the inside. So I think we're going to change up this design a little bit. Maybe make something that simply goes over the outside. I thought I had this designed already in my head, but we're going to have to make some alterations here. I'll do the other one off camera and come back and figure out what we're going to do. All right, I may have to make a new one from scratch. I'll show you why. This center drill fits into that bore that I drilled in there for the fuel to pass in the inside passageway, which is the same as the original one. It fits pretty well. We'll use it as a pin to locate this. You'll see what I mean. If this is the 1 and 3 and it's in like this, and we put that 2 and 4 here up like that, you see, because they're offset holes, this rotates off that center as well. I just don't have a whole lot of room in here to make this bigger if I made it again. But if I made it again, I wouldn't be able to offset it like that, because then I'd be putting it in on a thinner piece, because I'd be over to the side. Actually, it'd be this one here. Now, it's not that much. It'd be about maybe like that. So if I went and did a sleeve on the outside of it, the outside would be lined up fine, but the inside holes wouldn't. But would it make a hill of beans worth the difference? Probably not. And then at that point, once it's all cured up, and depending on how I attach it together, we can always run a drill bit in through here, which you can see is only going to be slightly off. It'll open up that hole a little bit. We can push it in right past the spigot. So this side will be a little like oval shape, but who cares? Ovaltine. I just would like to save this as opposed to making it from scratch, because it took me like half a day to make this. If I do something like this, I was thinking about using a piece of brass instead to make that centerpiece. It would overhang about 200 thou on each side, maybe 6 mil, 5 mil, which might be fine, because when we press it together, this is going to go together like this. It's two flat surfaces anyway, so it'll be fairly stout. And what we can do is also, instead of using Loctite, we could use Loctite, we could use JB Weld even to affix it when we press the second side in, or both sides for that matter. We'll do one before we do the other. I think I might try that, because then we have plenty of room for the hose. This is stronger than aluminum. It'll look kind of cool, and it's just about the right size, sort of. So I can get in here and turn it down, board out mostly. If I board out all the way, I'll lose this section here, but I don't really have any other brass, so I might try it. $595.5. So that's perfect. We're at $597. It gives me 1.5 thou crush. Nice. There it goes. Nice. Pretty cool. I think that's going to work. We'll have to deburr it, and what we can do is we can press it onto one side. We can certainly do that, because we only need it on one side right now, and then I'm not 100% sure with the Loctite. Let me think about it. All right, we'll put it in this side, the side that goes to 1 and 3 first. This is 305 thousandths wide as far as this way goes. So we'll push it down 155, and I'm going to just use Loctite. I'm not going to overcomplicate this, because I think it's going to be just fine. We'll set a 0 on the Z. There we go. Let's go 155. Three, 4, 155 right there. All right, so I checked it with a depth mic. It's actually at 145, so it's a little shy, but it went in very, very nicely. Ugh! I got a stinking leak in that thing somewhere. I got to figure out yet. Okay, so where was I? Yeah, that's an equal amount sticking out as we push down, and that took a good amount of force to get that to go in. And I'm really thinking this is going to work now. So this is the way it would be. So it would be in this way for 1 and 3. And whoops, goes this way, and then it would be up that way for 2 and 4. We just have to figure that out. We can't do that until we put the rack back together.
and get the fuel lines sticking out and get them in exact position that we want. Then we clock this where we want it to be, and we'll just do the same thing. We'll put it back in the vise. We'll just push down from the end here. Well, anyway, we're just gonna have to wait for that point, and then once we get the carbs back together and those fuel lines run, then we can really see if this is gonna work, test everything, and if I'm happy with it, we're gonna leave it. So my idea was, number one, you already saw how I've done 1 and 3, it came straight out, and as long as I have 2 straight fuel fittings, that works. Because I wanted to replicate this. I wanted it to come around and come over the top. I didn't press it together, but I tried figuring out how I could get a piece of regular Motion Pro hose to do this, and it just wouldn't work. It was too tight, potentially gonna kink. I originally made it just like that, where it was straight and parallel as far as the outlets, the fittings that go to the actual fuel lines themselves. So we really could have just left it in this original configuration. I made some assumptions. I thought I needed to change it. Ultimately, I didn't. Ooh, McMaster car. Machine tools. Folks, I hope you got something out of this video. Hope you liked it. I got to get those things packed up now. I got all the packing material and crap laying out on the lift. Got to go through all that. It's a big mess. But we'll go ahead and get those boxed back up in the box that they were shipped in. Contact the viewer and get those sent back up to him. I'm sure he's going to enjoy them. I did a second pressure test on them. You'll see that in video 2. The first pressure test that I did and the other findings as far as the static fuel test. They are 100%. I'm only mentioning that now because it's related to this fuel joint, this distribution tee rather, that I machined on this video, and it's 100%. I did not need to split it, obviously. I jumped the gun on that. I should have gone with my original gut feeling. I didn't. But watch video 2 on the carbs. It'll explain everything. I don't need to regurgitate it here. So that pretty much is it. As always, thanks for watching. Don't just repair, restore. We'll catch you on next video.